Oops. There we go. Hey, folks, let's finish up these notes here on the chain rule. So, find the equation of the tangent line. Boom. Let's stop right there. Equation of the tangent line. What does that mean we need to know? You should be getting to a spot where you can do this without me reminding you. If you want to find the equation of a tangent line, we need to find the point. The two things we need for an equation is a point. So that's at C, f of C. And we also need the slope. And remember, the slope is the derivative at that location. So for us, it looks like our point's going to occur where x equals pi. Okay, so we've got our function. I guess we could find the point first. That might be the easiest. So my x value is, so the point, the x value is pi. And I'm going to take this pi, I'm going to plug it into that. So we would get, so f of pi, remember f of x is your point machine, equals 2 sine of pi plus cosine of 2 pi. Nice, things are pi and 2 pi. Those are pretty easy to figure out. So this would be 2 times pi is over there at 180. Sine of that would be 0. Plus cosine of 2 pi, that would be 1. 2 times 0, so we would get 1. So our point is pi comma 1. Now we need to figure out the slope. So to figure out the slope, we've got to figure out the derivative. So let's look at our function and try to decide how we're going to derive this. So as you look at it, hopefully you recognize that this is a, what type of move you would apply. So this is a, looks like a sum with, so as I derive the sum, I would get the derivative of this. That's easy to do. The derivative of this is layered. That's a chain rule. So this is a sum with a chain. Okay, so f prime of x would equal to the derivative of 2 sine. Well, the derivative of sine is cosine, so the derivative of 2 sine is 2 cosine. And then we want to figure out plus, okay, so my outside layer is cosine. The derivative of cosine is negative sine. Dang it, I should have said it properly. My outside layer is cosine something. So the derivative of cosine something is negative sine something. Now I said something, so that means we've got to keep deriving. Multiplied by 2. All right, now we're going to start to try to figure this thing out. Let's see if we can clean it up a little bit. 2 cosine of x minus, I'm going to push my coefficients out front, 2 sine of 2x. So that's f prime. Well, we want to figure out the slope at pi. So now I'm going to do f prime of, and again, I'm going to put pi in there. Look at my terrible choice of colors. You guys can probably barely tell that that's, well, maybe you can see that that's purple or purplish. Oh, man, wrong button. Now can you tell better? Probably not. Equals 2 cosine of pi minus 2 sine of 2 pi. So now we can clean this up. So f prime of pi is equal to cosine of pi negative 1. So that'd be negative 2 minus 2 times sine of 2 pi is 0. So that's nice, which equals negative 2. So I've got my slope. I've got a point. Now I just need to put them together into our good friend. I like to use Taylor form. So the equation of the tangent line to the graph at x equals 2. So the tangent line to f at x equals pi is y equals y plus slope times x minus x. Box it in, put it up on our fridge. What do you think? Find the equation of the tangent line to the graph. Yeah, why did I have such a problem with this in the past? I don't know. I'll never know. All right, last page. Oh, I love these. These are so fun. Sparse data. I think these are a lot of fun. Okay, so suppose we've got a differentiable function. So that's huge. If they don't have that there, we're in trouble because we don't know what the derivatives are. But they've told us now. So we don't know that f and g are differentiable unless they tell us, because all they did was give us a couple of data points. But by saying that they're differentiable, we know that we can derive f and we can derive g everywhere. And their derivatives have the following values at x equals 2 and x equals 3. So we have function values, we have function machines, some point machines, We have point machines and we have slope machines. So we're going to do our derivatives down here. So what you have to ask yourself is, what type of rule is this? So I've got 2f of 3x over 2. So I've got something inside of something else. 3x over 2 is inside my f function. So this is a chain. Okay, so what's the derivative of 2f of something? So my outside layer is 2f of something. So the derivative of 2f of something is 2f prime of something. Look, you can't get a nice answer out of this. It's just f prime. We don't know what f is. So we just know that its derivative then must be f prime. Now, I said this was f of something, so we still need to times by the something. The derivative of 3x over 2 is 3 over 2. Okay, so now let's see what we can do. Now we're trying to figure out what's happening at x equals 2. So that's going to be 2 times f prime of, well, let's put 2 in there. Well, the 2's would cancel, and I'm just left with 3. Times 3 over 2. I don't know why I didn't combine like terms there, but I didn't, so we've got to live with that. All right, so now I've got 2 times, this is, I'll live with it, f prime of 3. So I go to my f prime table, go to the table, I go to my f prime column, I track down to 3, and I get 2 pi. So that gets replaced with 2 pi times 3 over 2. Those 2's cancel, but I still have another 2, so I would get 6 pi. Okay, let's try another one together. F of x plus g of x. So we want to figure out what's the derivative of this statement. So what type of rule is this? This is a sum rule. These are our favorite ones. Sum and difference. We don't have any layers. We don't have any functions inside of anything. We don't have any product rule. It's just straight up sum rule. So what's the derivative of f? F prime. Plus what's the derivative of g? G prime. And now we're going to evaluate them at x equals 3. So this would be f prime of 3 plus g prime of 3, which we can use our table to evaluate. F prime of 3 was 2 pi, plus g prime of 3 is 5. 2 pi plus 5 does not clean up. That's where we go. Okay, let's see if you can handle the next one. I did the 2 easy ones. You're doing a little bit tougher. So first of all, ask yourself, as we always do, what type of rule is this? Okay, so let's see how you did. Overall, this is a product rule. This is a product rule. Okay, so if we're going to do a product rule, what do we have to do? U's and V's. So U equals my first term, which is f of x, U prime. V equals my second term, which is g of x. And then we need V prime. Okay, so what's the derivative of f? Well, we don't know anything about f besides that it's just f, so its derivative is f prime. What do we know about g? Well, we just know that it's named g, so its derivative must be called g prime. Now we're going to apply the product rule, which is a plus. All right, so what would we get? We would get f prime of x times g of x plus f of x times g prime of x. And now I can start to plug and chug. I want to figure out what's f prime of 3, then g of 3 plus f of 3 times g prime of 3. All right, f prime of 3, I look at my table. F prime of 3 is 2 pi times g of 3, which is negative 4, plus f of 3, which is 3, times g prime of 3, which is 5. So 2 pi times 4 is negative 8 pi, plus 3 times 5 is 15. Maybe I'd like to clean that up a little bit by putting the negative term second, but I don't want to. All right, you try the next one. Hit pause if you haven't yet, because I'm going to start talking. Okay, so I'm at the spot now where I'm sick of doing U's and V's. So I know that overall this is a quotient rule. So I'm just going to do my U's and V's in my head. So the quotient rule is U prime V minus UV prime over V squared. This is my U, this is my V. This is U over V. So U prime V would be F prime times V, which would be G, minus U, which is F of X, times V prime, which is G prime of X, over V squared, which for us is G squared of X. Now, if you did U's and V's, you should have gotten the same thing. It doesn't matter if you want to do it my way or if you want to do it your way. We should still get to the same place. Now, I'm going to also be extra lazy here because I'm just going to use these to tell me where to look in the table for 2. I'm not going to actually now go through and write 2's in there a bunch of times because I can just look at the table and figure it out. So I'm going to do f prime of 2, which is 1/3. Corpy, I'm already annoyed by you because you gave me a fraction. G of 2 would be 2 minus f of x at 2 is 8 times g prime at 2, which is negative 3, all over, okay, g at 2 is 2, which squared makes a 4. Look at my fractions today. What is going on with those two division bars? OMG. All right, let's try to clean this up. So we would get 2/3. Negative times a negative is a positive. All over 4. Which equals, I got to get a common denominator here. So I'd have to times this by 3 over 3. So I'm going to be lazy. I'm just going to write it right next to it. If I times this by 3, that's 72 over 3. I always remember that because it's 72 hours and 3 days. So 72 plus 2 would be 74 over 3 over 4, which we can't do. So what we instead is take this as a fraction and flip it up so it becomes 1/4. So I can cancel now one of these. I can cancel a 2 out of this. So what's that? 736, 37. 37. So that won't divide by another 2, so then I'd have a 2 down here, 37 over 6. Maybe you need to show a little bit more work than that. If you do, do it. I don't know what to tell you. Do it. Do it. Do it. You can do it. All right. Moving on. F of g of x. What type of rule is this? What type of problem is this? This is, pause it, give it yourself a try. What do you think it is? All right, let's see how you did. This is a chain. This is a chain rule because I've got a function inside of another function. So who's my outside function? My outside function is f of something. So the derivative of f of something is f prime of something. Because I said something, I still need to do some deriving. So now I'm going to derive the inside. The derivative of g is g prime. Now here, I can't quite do the rest of this in my head. Maybe you can. But actually, maybe we can. So I'm going to put 2 in here. So that means I'm going to figure out what g of 2 is. So g of 2 ends up being 2. Well, that's kind of boring. And then that 2 is getting plugged into f prime. So f prime of 2 is, again, 1/3. Times g prime of 2 is -3. 1/3 times -3 is -1. And game over. Okay, you try the next one. Hint, hint, you're going to have to do a rewrite. Okay, let's see how you did. So I've got square root of something. So I want to rewrite this in a way that makes it a lot easier for me to derive. Okay, so I'm going to rewrite this as f of x to the 1/2. Notice I wrote a little arrow to remind myself that this is just a rewrite, that I haven't done any deriving yet. I don't like the way that he wrote these, and I probably could have changed them, but I'm too lazy in this case to change them to, I should have ddx in front of all those, but I don't. So this is a rewrite. Now I'm going to derive this. What type of rule is this? This is a chain rule. All right, so now I'm going to do the chain. Is something to the 1/2. The derivative of something to the 1/2 is 1/2 something to the -1/2 times, because I said something, my something is f of x. The derivative of f of x is f prime of x. This is going to be too much for me to do in my head, so I'm going to start to write it out. 1/2 times. All right, we're evaluating at 2. So f of x at 2, please be something nice, please be something, is 8 times f prime at 2. F prime at 2 is, oh gosh, 1/3. Man, oh man, he's being mean here. Okay, so we have 1/2 times, okay, so let's think about what happens to this guy. First of all, the negative is going to flip it to the bottom, and the 8 means, or sorry, the 1/2 exponent means a root. So I'm going to clean up that root over in the margins. So what I want to do is I want to take the square root of 8 and clean it up. Well, a perfect square of 4 goes into there, which means the 4 can escape and we get 2 roots of 2. So this ends up being 2 roots of 2 on the bottom times by 1/3, which then now we can put all of our coefficients together and get 1 over 2 times 2 is 4 times 3 is 12 square roots of 2. Crazy. The derivative part, the calc part, wasn't even tough. It was the algebra and arithmetic afterward that made that a sneaky problem. You try G. Again, I'm going to do a rewrite here because I don't want to do the quotient rule. You could do this with the quotient rule. It would work. But I don't want to do this with the quotient rule. So I'm going to do a rewrite, and I'm going to bump this from the bottom to the top, which means it's now G to the -2 of x. And then I'm going to remind myself what this really means. This really means that there's a -2 around this whole thing. So this is g of x to the power of -2. So I've got g of x is inside of this to the -2 function. So I'm going to do this. This is a chain. Okay, what's my outside function? Something to the negative 2. So the derivative of something to the negative 2 is negative 2 something to the negative 3. I said something, so I'm going to times. Now, wait a minute. What happened to this negative 2? Shouldn't that? No. We bumped it out around everything, so we don't have to worry about it. Now we have to derive the inside. What's the derivative of g of x? G prime of x. So we get negative 2 times. Okay, we're evaluating at 3. So g of x at 3 would be negative 4 to the negative 3. G prime at 3 is 5. Let's see how we do cleaning this thing up. So this would be negative 2 times. All right, so this negative 3 means I'm going to flip this to the bottom. And then the 3 means I'm going to go negative 4 to the third. So negative 4 to the third is still going to be negative. 4 to the third is 64. So I'm going to put the 64 on the bottom and the negative on the top. Now I can multiply all this stuff together. Negative 2 times negative 1 is 2 times 5 is 10 over 64. Those are both divisible by 2. 2 goes into there 5 times. 2 goes into here 32 times. All right. Last one. Oh boy. Get after it. You give it a try. I recommend your first move being rewrite. Rewrite this thing in a way that makes it easier, I should say, to derive. So I'm going to take this and I'm going to rewrite it as to the 1/2. And then I'm going to remember that these squares are really around each one of these. So let's rewrite it like this. The quantity of, again, of f of x squared plus then the quantity of g of x squared then to the 1/2. Okay, so this is, if I were to describe this, overall I've got something inside of 1/2, so that's a chain. With, as I derive the chain, the inside would be a sum. As I derive the sum, I'm going to have to do the chain again because these two are both inside of squares. So this is a chain with a sum with two chains. All right, let's get after it. So the overall function is something to the 1/2. So the derivative of something to the 1/2 is 1/2 something to the negative 1/2 times, because I said something. Now, the derivative of the something is a sum rule. So I would derive this piece and I would derive this piece. So as I derive this piece, this is something to the second. See if you can pause this and get ahead of me here. You can always unpause it and check your work, but see if you can get ahead of me without me just writing down what I'm doing. Okay, now I'm going to times by a group here, so be really careful that you indicate this with a parenthesis. So I'm going to try to derive something to the second, which would be 2 something. And I said something, so now I'm going to times by the derivative of that something, which was f of x. So the derivative of f of x is f prime of x. Plus, that was just the derivative of this piece. Now I'm going to derive this piece. So that's going to be something to the second. So that would be 2 times the something times the derivative of the something, which would be g prime. Now, you could try to clean this up here. If you're confused, pause and go back and think it through. Now, I could try to clean things up here if I wanted to, or I can just start plugging in numbers and then try to clean up those numbers at the end, which is a much better option. So I've got 1/2 times, okay, f of x, where are we doing this? At 2. So f of x at 2 is 8. And then I'm going to square that, so that's 64. Plus g of x at 2, I'm going up here looking at my table, is 2, and I'm squaring it, and that's 4 to the negative 1/2. Times by, okay, 2 times f of x times f prime of x. Actually, I'm going to write, this is going to be too much to do in my head. Times f of x at 2 is 8. Times f prime of x at 2, which is 1/3, plus 2 times g of x at 2 is 2, times g prime of x at 2, which is negative 3. Okay, let's try to clean this up now. So we've got 1/2 times 68 to the negative 1/2 times, this would be what, 16/3 minus 4 minus 12, which equals, all right, oh boy, 1/2 times 1 over the square root of 68 times, all right, so I'm now going to want to work on this thing. I want to turn this into an over 3 piece. So I'm going to multiply by 3, and I would get 36 over 3 here. 16 take away 36 over 3 is negative 20 over 3. And now, let's see if we can clean some stuff up here. Well, I'm going to try to now work on this 68. Is there a perfect square that goes into 68? I was almost grabbing my calculator. Okay, does 4 work? Is 68 divisible by 4? 68 divisible by 4. 4 goes into there once. 4, 28, 7. Nice. Oh, even extra nice. Because that means that that's a 17, which is prime. So 4 is the only perfect square that goes into 68 because we got a prime number. So I can rewrite this as 4 times square root of 17, square root of 4, sorry. Square root of 4 times square root of 17, which ends up being 2 square roots of 17. And now we can start to clean some things up here. Let's look at things that reduce. So I've got a 2 and a 2. So 20 is divisible by 2, which would be 10, which then is again divisible by this 2, which would be negative 5, over, I've got my 3 on the bottom and my root 17, 3 root 17. Now, I wouldn't be terribly disappointed if you stopped here. It would be really nice if you got to this spot, negative 5 root 17 over, what would that be, 30 plus 21 over 51. That would be your nice full credit answer. That would be a multiple choice answer. So what did I do? I had to get this root off the bottom, so I times by root 17 and root 17. So that left me with 3 times 17. 3 times 17 is 51. Lots of cleanup there, lots of cleanup. But the derivative itself, the actual calculus part, wasn't too bad. It was actually what we had to do after that made it such a interesting problem. Let's say interesting, right? All right, last example here for 2.6. Use the fact that absolute x is equal to the square root of x squared, and the chain rule to find the derivative of absolute x. For what values of x is f of x differentiable? What is the domain of f prime of x? So this is interesting. This is a pretty powerful move here in AP. When you're trying to derive something with an absolute value, we have a problem because how do you derive absolute value? Well, we can't. So a way to think about absolute value is to think about it as the square root of x squared. Well, you might say, well, wait a minute, what's the point of the square root in the x squared? Doesn't that just automatically make it x? Well, no, not quite. Because if you think about it, if you put any positive number in here for x, and you square it and then square root it, you'll get that same positive number back. But if you put a negative number in here, square it, makes it positive, square roots it, turns it back into the same number except only positive, which is exactly what the absolute value does. So this relationship is worth memorizing. This trick is worth memorizing. Memorize. Full disclosure, I always forget this move, so this is one that to me, I don't see enough of it to make me remember to do it all the time. Anyway, okay, so we're supposed to think of the absolute value as the square root of x squared. So we should derive that. F of x equals the square root of x squared. I want to do a rewrite here, which is equal to, the square root means that to the power of 1/2. Now, if you cancel this out, it ruins the power of being the absolute value. So don't cancel it out there. All right, now let's actually figure out what we get when we derive this. So f prime of x equals, what type of rule is this? I've got something inside of something else. Chain. And so we get 1/2 x squared to the negative 1/2. So it's something to the 1/2 is 1/2 something to the negative 1/2 times the derivative of my something, which we can then clean up. So 2 divided by 2 is going to cancel out, and then this is going to flip to the bottom. So I get x over the square root of x squared, which then cleans up to be, remember we talked about this at the very beginning, that if you have absolute, you can turn it into the square root of x squared. If you have the square root of x squared, you can turn it back into absolute. Does this look familiar? Have you seen this guy before? Do you know who this is? Senor Salta. Jumpman. Jumpman. So what did we just figure out? What did we just learn? That the derivative of absolute x is Jumpman. If f of x equals absolute x, then f prime of x is equal to x over absolute x, which is the same as absolute x over x. Jumpman. Pretty cool. Pretty cool. So the derivative of absolute value, Jumpman. All right, so that's it for today, or for section 2.6. Good luck on the homework.